or subtracting heat from some system doesn't actually change the temperature, but only changes the phase of that system. And so L here is not length, but is actually latent heat. And so this is either the heat of fusion or vaporization. So phase changes between liquid state, solid state, and gaseous state, right? So if I'm, for instance, I have a block of ice, right, and I put it in some water that is at some temperature that is greater than 0. Well, it will bring that water to 0 degrees by extracting heat from the water. And then, if there's still water left over, right, if I'm bringing out water to, or if the water continues to be there, right, it will start phase change, right? So now we have a block of ice sitting in some water at 0 degrees Kelvin, or 0 degrees Celsius, right? And then the block of ice will start to melt, and as the heat removed from that block of ice will go into the phase change of that block of ice. All right. So that's if we either add or subtract heat to some material, and the plus or minus sign here indicates the fact that we're either adding heat in terms of going from solid to a liquid to a vapor, or we're subtracting heat if we're going from vapor to a liquid to a solid. Right? So depending on which way we go in terms of our phase change, we're either adding or subtracting some value, but usually I think L is expressed as a positive value, so that's why we have the plus or minus here. All right, or L is given as a positive value, I shouldn't say expressed. All right, so heat transfer and conduction. So if we want to transfer heat from one place to another, there's different ways of doing it. And usually this rate of transfer of heat we represent with H, and that is equal to some change in heat as a function of time. So dq dt, derivative of heat with respect to time. And that is equal to some Ka times Th minus Tc over L, where K is a constant of thermal conductivity. And so this is the case in which I have two bodies that are in contact with each other. And whatever the material is that is transferring the heat between those two bodies has some thermal conductivity K. And then there might be some cross-sectional area to the area through which that heat can travel, right? And then there's some length. This is length again. Sorry, I shouldn't just indicate that's length. And there's some length through which that must travel. So the longer I make my connector between my two bodies, the harder it is for heat to transfer, the slower the heat will transfer through. The larger I make the area, the faster the heat will transfer to. So basically, the larger the contact area between two bodies,